Properties of the cross product. If A, B, and C are some vectors and C is a scalar, then the first property reads A cross B is equal to negative B cross A. Though the cross product is not commutative, but it follows this relation. If we commute the vectors, we get a negative sign. So we can think this expression as the following ways. Negative B cross the A vector, or B cross A, the vector, it's negative. The property 2 reads the scalar multiple of A, CA cross B, is exactly equal to C times the vector A cross B, or it's exactly equal to A cross C B. The third property says A cross B plus C equals to A cross B plus A cross C. This is called the lift distributive law. Or cross product. So cross product distributes over the addition from the left. Similarly, property 4 says A plus B cross C equals to A cross C plus B cross C. So the cross product distributes over plus sign from the right to. The fifth property reads A dot B cross C equals to A cross B dot C. Observe that in the left and the right hand sides, we have the same appearance of A, B, C, the same order, but the dot and the cross switched their positions. So without harming the order of this A, B, C, we can interchange the positions of dot and cross product. So they commute. The sixth property reads A cross B cross C is A dot C is a scalar times B minus A dot B, which is scalar, times C. So A cross B cross C is some combination of the vectors B and the vector C, where in this box we have A dot C, and in this box we have negative of A dot B. Please try to prove these properties with the help of the proof given in the book or notes.